My name is Addison Snell. I'm with Intersect 360 Research. We are industry analysts who cover high-performance markets, particularly high-performance computing and hyperscale, and that naturally lends us into other topics such as AI, big data, cloud, that span across those ecosystems. I'm going to give a very brief market update talk based on a public presentation I gave at the recently completed supercomputing conference, as well as some observations from there. And then I will be moderating the vendor panel to take our vendor sponsors through some aggressive, fast-paced questions. And to make it a little more fun, we've assembled a panel of judges who can assign them points and decide who did the best job actually answering the questions and not evading the moderator. So they're all primed, and we'll introduce that topic as soon as we get to it. One thing I want to make sure I don't forget to say, because I know there are many students here, a lot of the market data that will go by, they're from reports that are available from Intersect 360 Research. Those reports are available on our website. If you're a student looking for academic access to that data, one thing we've added recently is the ability to request reports for academic citation at no cost. You can find those forms on our website. Generally, we approve those as long as you just tell us what it is you're researching and what you're trying to publish. If you're not a student and would like to get access to those reports, we do also invite you to visit the website and put in your credit card number. That's a great way to get access to our research. Just a quick market update. Now, these are all 2017 numbers still. I get that we're late in 2018, but we won't wrap up the year until after the year ends. Generally get new year-end numbers completed around April or May of each year. But as a baseline, the HPC market is about it was 35.4 billion US dollars in 2017. That was up 1.6% from 2016. That looks like a very flat market, but in reality belies the fact that there were a lot of complicated dynamics that went on underneath that market. Some areas were actually up while others were down, and this is what that looks like graphically. Servers, the server portion, the compute portion of the business was up 7% in total revenue, and that took a larger portion of the budget specifically because of the effect of machine learning, deep learning in the market. We saw a similar thing happen with big data 5 years ago, where people were starting to mix in analytics with their HPC workloads, and the big effect it had in the market was people were buying more flash as part of their storage. Same total capacity, but more flash equaled more dollars per byte, and storage would be up more than the other portions of the budget. Same dynamic is happening here, but instead of flash and analytics, we're talking about GPUs and deep learning and machine learning, and now the server portion is taking a little bit more of the budget. That's why the servers are up more than the other components. Storage was also up, but only barely. The next three categories, network, software, services, all declined as the budget flowed into the more hardware-oriented portion of the budget. Now, cloud had a breakout year. It was up 44%. That really took off and crossed the billion-dollar range for the first time. If we take just that little green cloud sliver and blow it out, it looks like this. The bottom portion, which is raw cycles, just computing by the pound, going and getting some instance off a cloud provider, that grew 7% along with the rest of the servers market. But it's the more value-added areas above that, application hosting like SaaS or infrastructure hosting, IaaS, PaaS, those really grew. SaaS, in fact, more than doubled, up 125%. It's easy to say, oh, deep learning, but that actually wasn't it. It was more to do with the maturation of licensing models from the major software vendors in this space, and also the richness of availability of cloud-managed service providers like Cycle, which got acquired by Microsoft, but also companies like Nimbix or Rescale or RHPC all had significant effect in this market in enabling that transition. So this is the overall forecast. It looks fairly level. My business partner, Chris Willard, who's our Chief Research Officer, likes to say when you do a forecast, it has to be bound in some sense by what's realistic, whereas reality has no such restriction. Reality can go do whatever it wants. so we don't forecast things like wars or floods that can have a major disruption on the market. Now, that said, you can see in that green portion a much higher growth rate in cloud than in the other areas. Every product category, every vertical market, every region, every class of server from entry level up through supercomputer all have individual growth rates, and this is the aggregate that you're looking at here. The good news is that the budget outlooks from the demand side research have been going up, particularly in the government sector, which we'd been seeing as fairly flat for several years, not just in the US but worldwide. The Eurozone crisis and government sequesters, all kinds of things were holding back government spending. That's now showing signs of loosening up. There are fundamental drivers for all of this, the most important of which is that we like to say that the HPC market is a stable long-term market for the fundamental reason that we're not going to reach the end of science within the forecast period, right? That theoretically, somewhere out in the future, everyone could be standing cheering around the last scientist writing the last equation on the chalkboard, and then, great, we're done, we can go home. Science is over. But science tends to not be like that. And if you think, for example, to nearly 20 years ago now, we mapped the human genome in the year 2000. That sounds like the end of a problem. Great, you've done it. It's mapped. We're done. Finished. Can we go home now? Well, no. What you've just done is you've invented the field of genomics, right? And you have all of this additional research that gets piled on. So what's going to happen when we get the first comprehensive supercomputer model of a human brain, which will probably happen now within the next 10 years. Well, you'll have a whole new field of brain science, right? These are the kinds of things. Science begets innovation, begets engineering. More than half of the revenue that we've been showing in all this is commercial. And people are still going to want to make money and make money from making products too. We also see fundamental drivers for HPC in the cloud remaining strong through this forecast period. We do forecast the different server classes. Right now, the highest growth is concentrated in the high end of the market, and the lowest growth is down at the bottom with the entry level. So the supercomputers are getting a little more of the growth. We do look at the revenue by vertical. I'm not going to have time to talk about all of the different vertical markets here, but you can see that academic is just one chunk, is close to 18% of the revenue. Government is about a quarter of the revenue, and that's split between things that are like security, national defense, military kinds of applications versus government research kinds of applications in the research labs and the agencies. The difference between research lab and agency in this is somewhat pedantic. Agency is when it's a single focus, like a weather lab, like ECMWF, or the National Cancer Institute. If it's one specific agency, then it goes there. Then everything else is the commercial going around. Financial services is either the largest or the second largest, depending on whether you like to group together large product manufacturing, which is automotive and aerospace, cars, tractors, with versus consumer product manufacturing. When Procter & Gamble makes Tide Pods and they use HPC for the simulation. If that's one manufacturing sector, then manufacturing's the biggest. If those are split, then finance is the biggest. They're shown split here. Some of our clients like it that way. Two that I'll mention really quickly. I've been talking about financial services, but I put an extra arrow on it because out of all the talk of AI, we talk about fun consumer stuff like personalized medicine and self-driving cars. The financial services vertical market is the one that has done the most practical, on-the-ground, go-to-market AI work in HPC out of all of the vertical markets. You think you're going to have personalized medicine, you're going to have personalized interest rates a lot sooner that are going to proliferate. There's just a lot of money in doing that, and it's not as marketable, but I'm sad or happy to report, depending on which side you're rooting for, that that's a very real thing. Chemical engineering, I'll spend a second on. That's not chemistry like biochemistry, the molecular modeling. That would be down in the biosciences category, which is kind of the brick red color there. Chemical engineering here, I mean Plastics and polymers, companies like Dow, DuPont, 3M, BASF. I've highlighted that one because that's our highest growth rate segment in the forecast. BASF just installed the first petaflop supercomputer in the past year in this space, and we think that that's going to be the start of a real trend in this space as the HPC capabilities move from being strictly on the process side to being more in the molecular science and eventually the discovery phase of chemical engineering. HPC server shares, we also track. Most of them were up. The important thing here is that HPE is the narrow number one over Dell before it drops off to everybody else. We also use end user data in that. In this case, the survey data is very close to what we see with the actual market shares. If we look at the storage revenue, which we also segment, here Dell is the number one thanks to really it being EMC. People will think about Isilon as a component here, and of course that's really dedicated high performance storage, but really most of the revenue comes from things that just EMC sells an awful lot of, VMAX, VNXE, Unity, Extreme IO on the flash side. You know, it doesn't have to be specifically designed for high performance to get used by an HPC application and paid for out of an HPC budget. One other trend we did notice here is that more of the storage revenue in the HPC market last year trended away from storage-only companies towards server companies that were also selling storage. Interesting to see how the top three line up here because HPE is number one in servers, 3 in storage. Dell EMC, number 2 in servers, number 1 in storage. Lenovo number 3 in servers and now has a partnership with NetApp who's number 2 in storage, so they're all really consolidating there. We also have site census or end user survey data on that. This is where DDN comes up big, but DDN has more mind share in this case than they do market share. And this is indicative of that dynamic I was just talking about. If someone buys DDN, they're very likely to think of it in terms of being HPC storage, whereas if they use a VMAX partition out of their EMC corporate entity, they're less likely to think of it and mention it on the survey, even if they're spending money on it. So that's a little difference between survey data and actual revenue data. We have survey data on all kinds of stuff. I threw one in here on interconnects. The important thing here is that we've been monitoring Omnipath as it rolls into the market. Omnipath did get a pretty good bump right away in the market. The interesting thing was that it really took that share predominantly not away from InfiniBand, but away from the high-end Ethernet space. And as now the high-end Ethernet space might be heating up again, it's going to be interesting to see what the future of Omnipath versus InfiniBand and some of the other proprietary interconnects is in the market. And I might hit that again in the panel coming right up. I've got data on suppliers of all this stuff. I'm going to skip that. Top generally available applications. The point here is that as analysts, people want to ask us all the time, you know, what's the killer app that I need in order to go dominate a space? Like, what's the one thing? Like, everyone thought that if they had Hadoop, they could dominate this mythical big data space, which was never true. But people want there to be a killer app. And I try to say, well, HPC is not really like that. Well, fine. What are the 5 apps I need to get 80% of the market, right? Still not like that. Here you can see the top 10 apps combined, adding up to close to 1/3 of the market. And then after that, it starts being a really narrow tail after that with nothing adding up to even 2%. And this is after we've already taken out from this particular chart all of the in-house applications, which is in itself about 1/3 of the market, but all of it is an end value of 1, right? I wrote it, it's very important to me, it's critical to my workload, and no one else uses it, right? So if I put that in, it would squish everything else a lot further. Hyperscale market we also track in this space is distinct from high performance computing. When we talk about HPC cloud on the earlier charts, that was money that A company might pay Amazon to run their HPC applications in the AWS cloud, just to pick a cloud provider, right? That money they pay AWS goes into the HPC cloud market. Not all of the servers that Amazon buys in order to run all of their business. That becomes the hyperscale market. The hyperscale market is highly concentrated. It grew 25% year over year last year to $44 billion. It is consolidating further and further into what we call the top tier, which are companies that spend over $1 billion, $1 billion with a B, dollars per year on IT for their hyperscale infrastructures every year. Consider the order of magnitude difference there between hyperscale and HPC. A large supercomputer costs on the order of some hundreds of millions of dollars, the largest ones. The largest hyperscale companies spend 10 times that, billions of dollars, every year. That's like 10 of the world's largest supercomputers every year going into the largest hyperscale providers. We counted 9 of those tier 1 companies in 2017. That's one more than there were in 2016. One more that just missed. I thought there were going to be 10. I will tell you, of those 9 tier 1, one of them almost broke the $10 billion mark. It spent over $9 billion last year on IT. And I'll leave it up to you to guess who. You'd probably guess right. This market is, through its original major expansion, is going to keep consolidating the tier 2 and tier 3 into the tier 1. Now, there's AI, deep learning, machine learning. People ask, what's the size of that market? I'm going to back up for a second because you're going to read ahead and it's dangerous. Okay, when we size, I'm going to get like analyst pedantic for a second. Sizing a market, generally, for us as professional analysts, if we're going to say people spent this much money on something, we want to be able to, A, define the thing they spent money on, and B, be able to draw a circle around it and say it's the stuff inside this circle, and have that be something that's discrete and distinct. We never did that, our company, as analysts with big data or high-performance data analytics, this HPDA, because according to all of our research, it was never a distinct market. Yes, analytics was a big thing, but it got mixed into people's enterprise workloads. They used data they already had on storage they already had, with servers they already had, with people they already had. They might download some new software, but that was probably free. And overall, the top-level effect on the market, on budgets, was quite small. People didn't say, well, I got 80% more budget to go do analytics. No, it fit into the budgets they already had. Enterprise computing as a whole stayed almost flat over that 5-year period that we all went crazy around big data. So to have a separate market size around HPDA would imply that there's this separate analytics infrastructure somewhere, and that would lead a company to go do something hazardous like go produce a big data appliance. Remember in 2014, some of you, everyone who was rushing to the market with their big data appliances, and how many of them all failed, and how many are still around now, which is like none. It's not a distinct market. Okay, and that's, again, just a case study for coming forward to AI and deep learning. What's that like? Can I point to people who are running AI discretely? The answer is yes, and now I will go forward sometimes. Last year, there was about $4.5 billion dedicated to machine learning spending in 2017, but more than 90% of that came from hyperscale companies. Google, Facebook, Amazon, Apple, standing up dedicated AI infrastructures as separate from their other hyperscale infrastructure in a way that I could go in and point to the racks and say, these are the ones that are set up for machine learning. That's not to say that in HPC people aren't doing machine learning. They definitely are, but that's where it falls back to more of what we saw like with big data, where it mostly mixes into existing budgets, existing workloads, not always, but we're monitoring the spending patterns, and we have a whole report on this if you want more, about what the patterns are of it. Is it same budget, shared budget, different budget? Same people, shared people, different people? Same hardware, different hardware, shared hardware? Like, what's the deal? How does it affect an HPC environment? So most HPC organizations are already doing machine learning, or at least planning to run it out, but mostly that's not a big separate expenditure, except in finance, which is part of that part that's not the 90% that's in hyperscale. This is some of the data around that from that report. It says that, yeah, HPC sites are doing machine learning. So look ahead to 2019. We are going to see this AI augmented HPC idea beginning to take shape, and I'm excited about that, and I'm going to hit that in the panel as well. We are seeing early indications of strong growth this year, maybe even above what we forecast, but you got to give us a minute to get all the numbers in and actually add them up and fight about them as a team before we put out the market size. The processor wars are really fully engaged now and will be fought in software. You know, how are we doing with ARM? AMD is coming back into the market. Is anyone still going to do power? What's the role of GPUs? This all comes down to software, not just the specs of the hardware, and who has a good ecosystem going forward. And we're talking about exascale. You know, that's a long way away still for some of these platforms. We just put the first ARM system on the top 500 list this past a couple weeks ago. So we got one at petascale, and people are talking about ARM at exascale in 4 years, right? That's a long way to go, 1,000x improvement that fast, and I worry about the software more than I worry about the hardware. Storage tiering is going to continue to proliferate in the market. That gets more complex, and we saw some of the presentations on that just in the sessions preceding this one. The battle to possess data intensifies across the hyperscale space and across HPC. People want to do deep learning, they want to do AI, they need data for that. Whether it's consumer or business, the war is over who can not own the data, who can possess the data. If I get your data into my cloud, I win because I have the data and I can play with it, and in order to serve you better, of course. And I think acquisition targets, we're going to keep seeing that. Cloud managed services, will AWS pick up a company like Azure did with Cycle? I would say that could be likely. Middleware expertise is also going to be a hot commodity in this space as we talk about the processor wars and software. So those are some of the trends we're looking for this coming year. Okay, thank you very much for the market update. I'm Addison Snell with Intersect 360 Research. I'm now going to start bringing up our panelists for the very exciting vendor showdown, and while the rest of them take their seats, some are getting comfy in advance, I'll explain the fun format that we have for this. I love getting asked to do panels, and it has been my general observation over the years as I've done them that generally what the audience does not want is 5 consecutive PowerPoint presentations that are loosely connected on some topic. So we like to do things that are a little more fun, and in this case what I've done is taken our 5 sponsor vendors, who we very much appreciate, by the way, because if you like things like lunch and coming to conferences, well, they pay for that, and that's really nice, and you ought to listen to them while we're here. But I'm going to take them and having a South Africa theme here, I'm dividing the 2 teams into Team Springboks, which will be Intel and HPE. Springboks are the mascot of the national rugby team here in South Africa. And then we're going to have Team Proteus, which is the mascot of the local cricket team, and also I think netball, but let's focus on cricket for the moment. I did not use the soccer team because then I would be pinched between Bafana Bafana, which is the men, which means the boys, and Banyana Banyana, which is the women's team and means the girls, and we wanted to be gender inclusive, like you can see on this panel. Is Intel here, by the way? We can't do it without Intel. What are we going to do?
Yeah, it's 3 against 1, Addison.
Well, plus I gave Intel an extra question for being the diamond sponsor. Did they look at the agenda? Do they know that they're here? Does anyone from Intel want to fill this seat?
Does anyone who uses an Intel processor?
Anyone who uses Intel want to get up there?
All right, let me think for a second. Hang on.
2 and 2.
Yeah, I can do it. I just got to think of who I'm moving and what the questions are going to be.
Come up with something on the fly. If you'd like, I can speak for them.
I'm sure you could. While I'm thinking about that, I'm going to describe that the general intent is then give the panelists questions in pairs to start out. We've assembled a panel of judges who can award a point, one side or the other, to the Springboks or the Proteus. You may be familiar with Rich Bruckner from Inside HPC and Dan Olds from Orion X, both longtime mainstays. And then to make it fun in here, we recruited one of the students.
everybody clap because the smattering's just kind of insulting.
No, they were saving the applause because I visited one of the student cluster teams from WITS and said, I want to get a student on the panel of judges. Who should it be? And everyone unanimously nominated Sancha Gupta from WITS to join the team.
Right here. Very great.
And who knew the judges would outnumber the panelists?
Okay, so what I would like to do is have, it's Intel who's missing. Okay, well, that's just going to be.
AMD here.
AMD or ARM?
You know what? Now that we're down to 4 panelists, what we're going to do is not worry so much about the teams, regardless of what it says. We're going to go through the questions as they are, let anybody answer them, but the judges can still give a point to who they think answered it best. That's what we'll do. So you'll see Springboks and Proteus, and that was fun, but that'll be less important than the individual answers. So question number 1, which was going to be Intel, but forget it, and anyone can go after it. Considering the proliferation we're seeing of all the different architectures, all the different workloads, the incorporation of cloud and the drive toward exascale, what's going to be the greatest challenge that we're going to see in middleware over the next few years? This is a big topic I was just bringing up in the conversation. Now, Altair is here and was one of the top sponsors, so I'd like to let them go first, but everyone else can warm up their answers.
Okay, we're live. So for those of you who don't know Altair, we're actually a software company, and a lot of what we do is focused on giving application software to an engineering community. So the biggest challenge that we see in the proliferation of architectures and workloads and incorporation of cloud and so on is the end user. There are so many different technologies out there. Getting end user software to play nicely across all of these technologies and to make it easy for the end user to access it, this is our challenge, and this is something we're trying to address. Look, eventually, let's be honest, we as an HPC community develop the technology and we do our best to do good work. The end user really doesn't care where the job runs as long as it does. So I believe this is the biggest challenge that we're facing, is how can we make HPC in whatever format it is we come up with easily accessible to those users.
So accessibility is, you're going, is the biggest challenge in middleware. All right, we'll just come down the line this way. Yossi from Mellanox?
Yes, thank you. I think we've seen in the last 10 years many proprietary interconnects, which I think interfere when it comes to middleware, software, and economy of scale. The beauty when you have standard interconnects of the likes of Ethernet and InfiniBand is that you can benefit from the fact that you've got all of these best practices, all of these organizations that contribute, and you can use this as part of the HPC Council, which is open to everyone. You don't need to reinvent the things from scratch.
So biggest challenge is the proliferation of interconnects. We need to consolidate that. Okay, go Chris. Dell.
All right. So I would characterize this with, a lot of what we do today, managing the diversity of workloads across kind of these general purpose clusters. But as we incorporate cloud and we look at moving into this exascale, the difficulties of identifying the workload and making sure that it's being sent to the appropriate part, whether that be your on-prem data center or cloud-based solutions. Obviously, the cloud has a lot of promise when you come to these new technologies, and making those new technologies available to scientists to go explore their use in their application. But the ability to seamlessly transmit the data to the appropriate resources is, I think, going to be the biggest challenge.
Move the data to where the compute's going to be.
Yes.
Okay.
Yeah.
HPE.
When we talk about driving to exascale, it means that we have to think together from scratch. We have to reinvent the way to do exascale, incorporating what you are using today. So the greatest challenge is to put all together the actual piece and thinking about what would be the next piece of middleware and architecture we have to implement without disrupting your actual workflow. And what I'm surprised on your data is to see the lowest part of the storage. And for me, storage is your gold mine. I mean, more data you have, better you will be to achieve your goals in the future. So that's something also worries me a little bit, is the lack of investment on the storage capabilities.
Storage capabilities you're going with. Okay, anyone want to follow up on this while we're here on the topic on middleware? All right, well, then let's go to the judges. Go ahead, Dan. Who did you like up here?
I'm going to say the answers were, is this on? Am I here? Do you hear me?
I can hear you, but you need the mic on.
Okay.
There it is.
The answers were pretty good, but sort of in your own little lanes. You stayed in your lanes a bit. I'm going to give the point to Altair for actually addressing the middleware question.
I'm going to agree with Dan and say Altair as well.
That's the right way.
Altair, yeah, going with Dan's always a good way to go.
I'm going to go with HPE just to be a contrarian.
Go with HP. You know, I was actually really interested in which direction this was going to go, because there are a lot of really big ways to go with this. And since I put the word exascale on the slide, I was thinking towards scalability, but that doesn't hit the volume of the market. I think I would have gone with portability, especially of legacy codes, as being a major concern for middleware. But that's more on the developer tools side. But really, I don't think there's a lot of wrong answers here. I think there are a lot of different ways we can go. Next question, which Intel misses out on again, but Yossi, you're going to get a crack at this too, because this is right in your sweet spot. Looking ahead in HPC, what's going to be the role of the proliferation of proprietary interconnects that we're seeing on the market, such as Tofu from Fujitsu, BXI from Bull, NumaLink at HPE, Slingshot, the new one from Cray. Then we've got high-performance standards like InfiniBand and Gen Z versus Ethernet. What's going to be the role of these different categories of things in the market?
So thanks. That's a beautiful question, and I'm very glad
I thought you'd like that one.
And I'm glad to talk about it. So first, I will add to the list of the proprietary interconnects also OmniPath. And I think that we've seen many different proprietary interconnects throughout the ages, and they are not here with us anymore. So look at Cray Aries, it's declining, it's out of the market. Look at Quadrix, those who remember. Look at Mirinet, all of those are not here. So the advantage of going standard is that you protect your investment. And many clusters that we come across are built in stages. For example, let's take the most powerful supercomputer in Africa, which happens to be here in South Africa, and we have 3 generations of FDR, EDR, and even DDR from before still working together in a tandem. Try to do it with proprietary interconnect, good luck with that. So you protect your investment in a very clear way. The advantages also of standard are ensuring the backwards and future compatibility. As said, protect your investment. I think also it's very important to say that as long as you are part of the standards, you can benefit from the HPC Council with many, many best practices across simulation, be it crash simulation, be it for the automobile industry, be it reservoir simulation for the oil and gas industry, so this is classic. I would not even list Gen Z next to InfiniBand simply because Gen Z still does not exist, and when it exists, like, we can talk about it. But
it's a future-looking question.
Future, yes, but you know, we're trying to talk about something that we can buy today. Now, Ethernet and InfiniBand...
Look, it says looking ahead in HPC. It's the first...
You know, customers tell us, show us the money. And when we talk about InfiniBand and Ethernet, our CTO talks in terms of Ethernet and Ethernet. And InfiniBand is obviously Ethernet. This interconnect was designed only 20 years ago for SDN, where nobody even knew how to spell SDN. So the fact that it is a lossless interconnect, the fact that it allows for CPU offload through RDMA, the fact that it gives you the opportunity to do I/O consolidation, all of these leading to the fact in the market now that in the last top 500 supercomputers of November last month, guys, first time ever, InfiniBand is the majority of the interconnect from the top 500.
That's a good point. Go ahead and hold the mic for a second. I'm going to let you rant on this for a minute because I know this is right in your sweet spot.
Yeah,
I do want to...
Just because I respect Matthew so much, I'm holding myself.
No. as the moderator and the guy who put together the slide, I am going to say I left OmniPath off of this specifically because it's an awkward tweener between the proprietary category and the high performance standard category. You're going to, I know, say it's proprietary,
Blasphemy.
but
It's blasphemy. It's absolutely non-standard. Try to go OmniPath Gen 1 and Gen 2. Good luck.
great. That's why I let you hold the mic. All right, bring it this way, Chris. Go ahead, Del.
Who wants to follow that?
Del does.
Oh, excellent. So we at Dell EMC have really adopted the standards-based approach. And I think it's really from the back to the very core of Dell EMC, really adopting the standards approach all the way through our PowerEdge servers. And so I think that's really at the core of providing the right level of competition for vendors in the industry to bring new and compelling technologies to market. And we work very closely with all of them to make sure that there are no two HPC workloads identical. And despite what Josie might say, there are some applications that have performed exceptionally well on OmniPath. But what I would say is we want to make sure that all of those technologies are available to you so that you can make the most of the science.
Okay, great.
Be honest, I'm a little bit surprised to see NumaLink into an interconnect segment. It's more a way for us to have a 32-socket system being built. So it's not, and when it comes to...
Way back in my career, I worked at SGI, so it's hard for me to let go.
Right. So I'm surprised. So when it comes to then going out of this 32-socket system, we use InfiniBand, for instance. And for me, InfiniBand and Gen Z together, again, Gen Z is more like a PC Express competitor with the next generation standard, which Mellanox is part of this consortium. And
I could have listed NVLink, C6, there's a lot.
InfiniBand Gen Z system will exist in the future. Okay, so so we initiated. We are part of this consortium of Gen Z. This is why we do it. Is because we think that to do exascale with the current infrastructure data center that the world is having today, this is the only way to move data, to move information at the lowest power cost.
Okay, great. Back down to Altair. Do you want to weigh in on the interconnects, or you're afraid Yossi's going to hit you?
We'll give you another shot. So I'm going to go with the standards, and the reason I'm going to do that is, I mean, if you think about the technology of the future as we head to exascale, maybe even further, at some point we're going to start to hit the physical boundaries of what perhaps silicon can do. We're going to need entirely different paradigms of HPC. I mean, Professor Sterling spoke about that last year. He'll speak about it again this year. We heard talks about quantum computing today. The only way to make meaningful advances in all these fields is to really plug together as a community, I believe, and that requires standards.
All right, let's go to the judges.
Okay, I'm a man who respects passion. Yoshi, you get that? I do appreciate the delicate sidestepping on eggs that you were doing at Dell. That was exquisitely done. But I've got to go with Yoshi on this one. He's pointing to the scoreboard. Scoreboard, you get a point from me.
All right, there you go. Sancha.
I'm going to go with Mellanox as well, simply because he really seems like he knows what he's talking about.
I would say on this topic, I think he does.
Real quick. He may not always be right, but he's always certain.
It seems that way.
Yeah, I go with Mellanox as well.
Swept the category.
Yeah, I mean, he's right. No proprietary interconnect company has ever survived, and I don't think they ever will. I tried to tell this to the people at Extol, which didn't even make your slide, by the way.
For sure.
Because they can sell one or two to a couple of universities, but that's not a business model. So
really good point. My quick analyst comment is that for me, it comes down to how far ahead I'm looking. I think in the short term, we are going to see a blip up in all of these proprietary interconnects as the proliferation in processing elements begets more interconnect choices. So those will expand, but eventually they have to contract again. So it just depends how far ahead we're looking. All right, next question. question. This was already set up for HPE and Dell, so they're going to get to go head-to-head first on this. But from hardware, software to cloud, much of the debate has been coming down to components like the processors, the interconnects, the storage components. How do you provide a complete solution that's valuable beyond being a collection of parts, Chris?
So for us, I think a lot of what we're doing is really a strong investment into the HPC community. We do so with our HPC and AI Innovations Laboratory, managing a system that's, properly represented on the top 500 list. I will call them scientists, our engineers in our lab. These are folks from industry who have a long history and in the industry doing the related sciences. And so it's really around everything from not only the software applications, because there's a lot of that, a lot of providing guidance in terms of some of the tuning of the both software and the hardware, to eke out even every little bit of performance. But it also comes down to just some of the more straightforward challenges that our customers have, or that HPC users have, in terms of managing these huge clusters. And so that also offers up some particular service opportunities for us to go help and identify and address some of those service opportunities.
Great, thanks. HPE.
I tend to agree with Dell. It's me. It's the HPC experts, engineers we have, which with you make things together, because answering to a tender which is providing a BOQ above of materials, it's easy. Everybody can do it because you have done the work. So this is the most important. On top of that, by talking with you and working with you prior to any investment, we are able to provide and put on the market a solution will answer your needs. For instance, we have a solution called HP Green Lake. What is it? It's to put in your premises an HPC infrastructure which is sized to answer your needs immediately, plus we put a buffer of 10 or 20% hardware of such a solution to answer your workload, and you pay per use. And then if you have an increase, then we add more hardware at no cost for you, except that you pay what you are using as an hardware. So this is a way to answer, because I'm a believer, and this is a solution I'm pushing, that doing HPC on the cloud is not the acceptable solution, because HPC solution and the result of the HPC, which is the most important, is the critical assets of every single organization or commercial entities in this room. So putting this into the cloud, and you mentioned it, that everybody can access and use it, the data you put on the cloud, this is strategically surprising for me if you go that path.
Yeah, it's an interesting shot at the HPC cloud as the primary solution, giving up the domain expertise that you would keep with the primary vendor then if you're doing that. Interesting take. Okay, go ahead.
Yeah, I'm going to take the user perspective again. If we think about the user community of even systems like CHPC's Lingao, whether it's chemistry or weather services or engineering, eventually every problem has a particular use case, and this is what these scientists intend to do. They want to solve problems. So if we can combine a system that is properly spec'd for that particular science or competencies requirements, that's our first challenge, is to understand exactly what the compute requirements of that field are. The second is to plan and support them. I mean, these people are not IT specialists. A company like you referred to BASF earlier, who's got a petaflop system now, they're not an IT company. They're not an HPC company. They're a science company. So if we can provide services to go along with that system to sort of mitigate any of the challenges of running an HPC, that's wonderful. So the less we can expose our clients to HPC, I guess, that's how you make these systems valuable.
All right, Yossi, you've got a chance to catch your breath. You ready?
We'll say it simple. We love them all. We're agnostic. We'll work with all of the OEMs out there. We're standard. We will work with all the CPU architectures, be it AMD and Intel x86, be it Open Power, be it GPUs, be it FPGAs, be it ARM. We're agnostic.
Okay. Chris and Antoine, you gave similar responses. Anything you want to add on top of your previous responses, or do you want to stand where you were? All right, Olivier, I'm sorry. Okay. All right, judges.
I've got a quick question for Altair. Were you basically talking about designing and building systems to the workload, to build them to fit the particular workload?
Yes.
Okay, you get my point. Good job.
All right. Sancha.
I think I'm going to go with Altair again. I'm not
Altair
following
again.
that, I promise.
The right way to go
But
every time.
what he said made a lot of sense because as someone who is very new to this whole HPC thing, I think what he said is really
Hide the HPC from the end user.
I'm going to go with Altair as well, because you know what? HPE and Dell are very successful, and their customers love them. I've been to both their user meetings. It just wouldn't be fair to pick one and say one's better, because they're both right. So Altair is good for me. Yeah. That's right. That's right.
You know, I agree that it would. I would have gone with one of those two answers, and I would have had a hard time choosing between them. But I like the focus in particular on domain expertise as an area where it can really help out. So I would have been more over here, but I would have had to think about it longer to decide which way to go. But I appreciate your feedback and the fact that I made you do it. Okay, two other questions that were set up, and these were already designed for everybody, but we've talked a lot about AI, and what we're leaning toward, a big trend that I saw at supercomputing is really we're coalescing around not AI versus HPC, but AI augmented HPC. What do you see as some specific examples of the confluence of AI analytics and HPC that we're going to see in real deployments in the near term? Go ahead, Olivier.
I live in a country, I'm based in Dubai. They invested, we have an AI ministry, and we have also an happiness ministry, for your information. It is not linked. So for me, it's security. So I know by driving, they put a lot of cameras everywhere in Dubai. They know at the second where I'm going, okay? I don't know why, okay? But at least they implement it. So for security, for sure. We do it also in our factory to control the quality of the server which is going out of the factory. This is what we are doing. So we use our technology. It's really, for me, I'm selling the solution to see that my company believes on the solution we are providing. So it's a relief for sure. But for sure, money today is on the security side, I mean defense side overall.
Security and defense, yeah, there's a lot of money there. Go ahead.
Yeah, I'm doing the self-styled user champion here. So again, on the AI side, what we like about the perspective of AI is in helping us understand where to probe for consumer problems and how to design these things. Eventually, even with large computers, compute cycles are in limited supply. So if you're going to do crash analysis on a car or engine analysis on an aircraft, AI can help you decide where to focus your effort in designing a better product. However, as soon as those things get deployed, there's lots of data around it. Analytics of that data can help you identify where your products in the field are deficient or where they need service. So if you can use your analytics and your existing models that run on HPC to give better client support and help them understand when to do preventative maintenance, when to not take off in an aircraft, that's where you're going to win. I'd really see in sort of safety and safety product development is where AI and analytics combined is going to have the most effect near term.
All right.
So artificial intelligence, when it's done right, allows you to create powerful software algorithms, which in turn can increase the accuracy of HPC simulations. So imagine you can do your crash simulation, reservoir simulation, weather forecast simulations in a better way. So we think those two actually go hand in hand. They also have the same technology needs, especially the likes of RDMA, which is becoming, together with InfiniBand, the de facto standard for both AI and HPC. I would say more than that. Most people don't tell stories, and I think the ability to tell stories is a dying art. So I'd like to share with the audience a quick story. Imagine you're at home and your significant other is not at home and your kids are screaming at you that they're hungry. You're panicking and you order a family pizza. You call the guys, what do? They take the dough, they shove it into the oven, they bake the pizza for you, they call the truck, and they rush the pizza in the truck straight to your home. So you're looking at two specific building blocks of time blocks. One, the baking, and the other one is the delivery. The InfiniBand approach is simple. How about we make the network part of the computation? Because trying to run everything on a multi-purpose host CPU will not take you where you want to go. Yes, throwing more CPUs into the problem is actually allowing you to have and bake more pizzas. But from your point of view, you're still going to wait until it is baked and until it is delivered. The Mellanox approach is, oh boy, let's take the oven, shove it into the truck, and bake the pizza when the truck is already on the way to your home.
So this is an area where we're already starting to see a lot of these, a lot of our customers, doing this. And it's an area that's of particular excitement for me. We had the IoT wave that came, which really brought about putting sensors in absolutely everything. And it's analytic in so much as I know I need to go get eggs because my refrigerator told me to. But one thing Michael Dell says is he says companies will succeed or fail based upon their ability to put data into concrete business plans and strategies. And I think that's really at the core of what's happening here. And so in the areas of research, one thing that I'm excited about is this AI is allowing these scientists to go take a look at all of these very separated only by one small variable, and really accelerating their ability to quickly turn and focus on what is the next great area that I need to be going and dialing in my limited time, my limited resources. So I think in the area of research, it's particularly powerful, but I'm really excited about some of the commercial and enterprise applications here. So this convergence of AI and data analytics really doing what Michael had talked about, and really making sure that companies are really able to harness the power of their data.
All right, judges, have at them.
I just came off of a tour of 7 national labs, and 6 of the 7 were talking about using AI to inform their brute force simulations and modeling. And that's a very big deal. So I'm going to give the point to Dell because I think you got closest to that. Nicely done. Although I did like the pizza story. Very good. Very good metaphor.
I'm going to go with Mellanox for the pizza story.
Students love pizza.
Yeah. One of the student cluster teams, by the way, is named Will Code for Pizza, but I'm going to go with Dell.
All right. I really like those answers too. I did, we already talked about finance. I did on our weekly podcast this week in HPC just recently interview a doctor from a team at Stanford that did a wonderful combo HPC, machine learning, big data on personalized medicine, a genomics application for heart disease. I'm also looking forward ahead to things like computational steering, AI in the loop. That's going to be a big deal when it happens. All right, last one, hyperscale versus HPC. We talked about the hyperscale market, how big it is relative to HPC. You get these dominant users. What are some of the most significant influences, both positive and negative, that the hyperscale market has on the HPC market, both currently and in the near future? Whoever wants to dive in first can dive in.
I'll jump in on that. So one of the, I've been in the HPC community at Dell here now for more than 6 months, but the thing that I've been kind of surprised by was how closely the synergies exist between my hyperscale counterparts at Dell EMC. I think there's a lot of synergy between these two markets in so much as hyperscale is really kind of paving the way for the absolute most efficient use of data center resources. So really clever designs that really kind of address some of the power and cooling requirements. And where HPC is at its strength is their ability to tweak all of the knobs under the hood to eke out every last bit of the performance. And so I think there's a lot that we can learn on the HPC side from the hyperscale folks. And similarly, I think there's a lot that they can learn from us.
All right. Next, who wants to go?
Yeah, I'll have a go. So I like to think about almost as hyperscale as a stepping stone to HPC in some way, in the positive sense that for users that maybe are considering HPC or they don't appreciate the value yet, Hyperscale, via the likes of Amazon and Azure and so forth, offer an opportunity to experience it and play with it until you're willing to spec your own HPC system. So positive, it's a nice method of offering a business model and an introduction to the technology initially and then scaling up. Negative, almost the upscale of so many compute cycles sometimes might make young scientists lazy. You trust simulation more than you do fundamental science and understanding because you can just run a simulation. So fundamental understanding might take a bit of a backseat the more we have things like Hyperscale available to everybody.
All right, excellent. Mellanox, go ahead.
So the way we view this is that a hyperscale is basically a supercomputer which is for a single application. And when you look at things in this way, they're shared some of the technologies needs for HPC. We'd say that we see hyperscale companies turn into RDMA and InfiniBand for AI and HPC applications. This in turn help to run the economy of scale.
All right. Olivier?
Influence, financial power, positive, challenging everybody on the technology side to develop, to help us and to help each other to develop a new technology because going forward we have to reinvent the way we do HPC, unfortunately, because mainly power. We are lack of power in our data center, so we have to use the actual capacity to do it. Negative, is we cannot live anymore in the Bay Area. The real estate there, it's far not affordable for all of us, and they are drying out the HPC also resources by hiring key people to develop their own technology also. This is a negative asset, proprietary technology.
Excellent. I think there are a lot of effects that they have here. Some of the most positive ones right off the top are it's giving us cloud, and it's giving us a lot of development in terms of AI. A lot of those are coming right out of the cloud space. In the longer term, we might get some new languages trickle over into HPC, like Go or Julia. We're starting to see some uptake on. On the negative side, they can draw a little bit of innovation into hyperscale first versus HPC first, and I get that, but the biggest thing is the talent drain. They're sucking in a lot of young employees, and it's harder to find people who want to do HPC rather than go work at Facebook, Google, Apple. Judges?
Not sure exactly where I'm coming down, but I tend to agree with me. And
should I put a point in your column?
Maybe, because I think that a lot of the impact of hyperscale is kind of negative on the HPC market because it leads to a homogeneity of resource, and that's against the point that I gave you earlier, Altair.
You want to take a point away from Altair?
I do. I think I do. And as Dr. Henry Newman on our podcast, Radio Free HPC, says, that the HPC market needs more heterogeneity in terms of configurations, things that you could do and stuff like that, that hyperscale is kind of taking away. And so I'm giving the point to me for making that point.
Why not? This is degenerated enough so far. Sancho, are you going to give the point to Dan too? Please don't.
It's up to you. You're the judge.
I think I'll go with Dell. It's okay.
All right, thank you. Rich, last word's yours.
I'm going to go with HPE. So we're going to have a non-vote here because we should have 2 out of 3, Dan. And
You're not going to go with me?
I'm not going to go with you. No, because here's the problem. The hyperscale market is going at a velocity that is 10x HPC as far as rapidity of change. And we're going to get left behind, guys, here in this space. We really are. And we should pay attention to what's going on in hyperscale. And I know at the vendor level you guys are. Of course you are. But the users in Dallas at SC got their head in the sand. Okay? They just do. And the negative is the talent drain. Okay? These Google kids get to ride around in a bus and play ping pong on the way to work and get massages and their laundry done at work. How the hell is a national lab going to compete with that?
Good question.
Okay.
I'm going to move my point to Rich. That helps out.
Yeah, it does. All right. Well, and these points really can, and I appreciate you putting it on to you or Rich rather than taking it away from Altair, because we have a winner, and it's Altair has won the vendor showdown. Thanks very much. Very close. I had to put on my glasses to see. But the bigger point is that all the vendors got points, and we had a lively discussion. And I appreciated everybody listening into these opinion-driven questions about the future of HPC. Thank you to the organizers for having me here again. Happy, do you have closing comments for the day? Everyone's supposed to come to the Bri?
Okay.
Come to...
The people who are supposed to be at the performing the prayer are not there. Thanks to Yossi, he killed the competition.
Well, why don't you come up here and say that? Okay, thank you very much, everybody. We'll see you at dinner.